Hello, welcome to my channel. In this video, we are going to be looking at problems under momentum. So the problem we want to solve under this topic, under momentum, is given in the form of a diagram. So from this diagram, we have the problem also in the form of a statement, which reads, what speed of the bullets can make the wooden ball cover a distance x? This distance x, if the bullets and the ball stick together after collision. So this is the bullet traveling with velocity u, strikes this wooden ball, and after collision they stick together, and this ball travels in these paths. So the question is, can we find the speed u in terms of y and x? So for us to solve this problem, we first of all assume that the mass of the bullet is given as small letter m. The mass of this wooden ball is given as capital letter M. Now, we apply the conservation of momentum. And the conservation of momentum states that the addition of all momentum before collision must be equal to the addition of all momentum after collision. So the momentum of this bullet is mass times the velocity u plus the velocity of this ball times the mass of this ball. That will be before impact. Then, because after collision, the ball and the bullet, they stick, what happens? Then, the final mass of these two systems will now be capital letter M plus small letter m multiplied by the single or the final velocity, which is given in the form of an equation as this. So we have mvb plus m, which is the mass of the bullets, times the velocity of the wooden ball, equal to when they stick together and one final velocity. But remember, this particular ball initially, before the collision, was stationary. So that means everything here will be 0. So we have mvb, which is the velocity of the bullets, plus 0 equal to this expression. So we can make VB the Soviet formula, and that gives us VB equal to M plus M, capital letter M, multiplied by V all over M. But you'll notice that this velocity is not known, but we can find this velocity in terms of our Y and our X. And for us to find the velocity in terms of Y and X, we consider that this ball travels through these paths, and these paths taken has a form of a projectile motion. So we are going to engage the projectile formula to solve this particular problem, and that's given by this expression, where y here is the height of the table, x is the distance from the foot of the table to this point traveled, theta here is the tan, the angle, but because it is moving horizontally, our angle theta is equal to 0. So our V here is the speed of the ball and the bullet when they stick together. That's after collision. So from here, when we fix in all those values, we notice that we have our minus y equal to x tan 0 minus gx squared all over 2v squared cos squared 0. And why are we taking minus y? Because since the ball is starting from the origin, it goes below the vertical. It goes below, so it takes a negative value. That's displacement. So it takes a negative value, which is minus y, equal to this expression. Tan 0 is 0, cos 0 is 1. So everything here will reduce to minus y equal to minus gx squared all over 2v squared. So our minus can take care of this minus, and at the end of the day, we can make v the Soviet formula, and we have v squared equal to gx squared all over 2y. And v becomes square root of gx squared all over 2y. Now, from this point, we notice that this v tallies with the v of the combined bodies after collision, which is capital letter V. So we have something of this form. Our V here is equal to capital letter V, which is equal to gx squared all over 2y. So if we recall from where we stopped, VB, the velocity of the bullet, is equal to mass plus capital letter M, which is the mass of the wooden ball, times v all over m, we notice that our v is now this expression. So we can remove this v and replace with this. And at the end, we get this expression. So this is the velocity of the bullets in terms of the distance traveled and the height of the table, the masses of the individual body. So what you notice here is that as x, you can find your x in terms of your b, or you can find your b in terms of your x. So once the velocity of the bullet is known, we can determine or we can predict the distance traveled. Once the x is known, but we don't know the speed of the velocity, we can know the velocity of the bullets. Our y here is constant. Every other parameter here is constant. So I hope this helps. Please like, share, and follow for more videos.